Okay, so now we're going to start studying circuits that are a little more complex, circuits that cannot be simply broken into simple series or parallel parts. And in order to tackle these circuits, we're going to need something called Kirchoff's laws to be able to solve the circuits. Now, let's look at a couple examples here. Now, the exhibit A here, okay, if you look at example A, in this circuit, you cannot simply break any part of the circuit down into simple series of parallel parts. In fact, this is a very complex circuit. It's a tedious problem to solve, and hopefully by the time you understand your laws, you're able to solve the circuit. Okay, another example where you cannot simply use the rules that you've learned so far to figure out the currents or the effective resistances is example B here, where you see you have multiple sources. You have two voltage sources here, and that's what complicates things. Okay, so having said all that, let us understand Kirchoff's laws first, and then we'll do an example that will take care of how to go about solving everything. So there are two laws that one must understand. Okay, the first law is called the current law. So this is Kirchoff's current law. Now what this law says, that at any node, okay, so if you have a node, some node, so let's say, I'm just kind of exaggerating these wires, so let us say we have these nodes. Okay, at any node, the the current entering the node has to be equal to the current that is leaving the node. So if you look at this node here, this junction here between these four wires, okay, we have I1 and I3 that are entering. So I1 plus I3, okay, and this is equal to I2 plus, oh actually I meant to call this I4, plus I4. Okay, so what we have is, what it says is the current entering any node is equal to the current leaving the node. Okay, so whatever enters the node must leave the node. So that's it. It's a simple law, no problem at all. Alright, so this is the first law. The second law, second of one of Kirchoff's laws, is called the voltage law. Okay, it is also called the loop law. So what it says is that the sum of the voltages around a closed loop equals 0. Okay, so let us understand this. Let us see what this means. Let's look at the simplest circuit possible. So let's say I have a resistor and I connect a voltage source to it. Okay, delta V, and let's say the resistor is R. Now when the circuit is complete, we know that a certain current I will flow through this loop. Okay, now we also know the equation, which is delta V equals I times R for this loop. Alright, but if we were to move the IR to the other side, okay, my equation would end up looking as delta V minus I times R equals 0. And what this equation says is that the sum of the voltages around the loop is equal to 0. So let's make sure we understand this. The first thing we'll do is, and the first thing that you should do when you have any loops where you're going to apply the voltage law, is place the appropriate signs, the positive and the negative signs, on each element of the circuit. Okay, for the battery it's always very clear. Okay, the long end is the positive, the short end is the negative. Now for the resistors, you must follow this very simple rule. We know that current flows from high voltage to low voltage. So if through the resistor the current flows in this direction, clearly the left is going to be high and the right is going to be low. Okay, now that we have all this taken care of, what we'll do is we'll take a loop direction. Now just for convenience, I will always stick with a clockwise loop direction. And what it says is, as you go around the loop, if you were to sum up the voltages, okay, for each element of the circuit, that sum will end up being equal to 0. Okay, so let's see if this works now in this case. So we have delta V in the direction of the loop. As I go in the direction of the loop, let's keep in mind that if you go from negative to positive, you're going from low to high, and when you go from low to high, your voltage is increased. So we will write a plus delta V for the voltage of the battery. Now for the resistor, as I move in this direction and I go through the resistor, you see I clearly go from a high to a low, which means the voltage difference is going to be negative, and hence for the resistor I know that the voltage is always going to be IR, but I need to put an appropriate negative sign there, and this will be equal to 0. Okay, so understand this part. Just reply this part if you have any doubts about this. And what I'll do is I'll take another loop and I'll follow the same principle for this loop, and this should really clarify the law. So let's say that we had a circuit that looks like this. Okay, and let us say that this is some R1, this is R2, and this is R3, and let us say that we have some currents. Let's say I have current I1 in this direction, I have some current I2 here, and let us say I have some current I3 here. Okay, and okay, this circuit itself is, let's say, part of a much larger circuit. Now let us write the loop law for this. Okay, now before you write the actual equation, the first thing you always do is put the appropriate sign for each of the elements. For the battery on the left, okay, this one was delta V1 and this is delta V2. Let's put the signs, and clearly for the battery the signs are negative, positive. Okay, so it is negative for the short end, positive for the long end. Now for R1, if you look at the branch with R1, the current goes up in this branch, which means that the voltage below has to be positive and the one above has to be negative. Okay, because it's going up, and we know current goes from a high to a low. Similarly for R2, the current goes down in this branch, and as a result the upper part is going to be positive, the lower is going to be negative. Okay, and then for delta V2 it's easy. Now for R3, the current is going to the right, so the voltage is going to be plus to the left, and it is going to be minus, because current will go from a high voltage to a low voltage. Great, we have this. Now we can write our equation, and let's start with delta V1, and once again I'll go in a clockwise sense. So if I start at delta V1, I go from low to high, so it is plus delta V1. For R1, I go from high to low, so it is negative I1 R1. For R2, I again go from high to low, so it is negative I2 R2. For delta V2, I go from high to low, it's minus delta V2. And for I2, for R3, I go from low to high, and so I got a positive I3 R3, and the sum of all these is equal to 0. Okay, so let's make sure we understand this. Once again, I'm going around the loop, so follow the equation again. I'll just use I guess this is green for the loop thing, or maybe it's tough to see, so maybe I'll use blue. Okay, so I'll start with my delta V1, okay, and I'm going to go in a clockwise sense. So as I start at delta V1, you see I go from minus to plus. So when I go from minus to plus, I'm going from low to high, I have to put a positive sign, so that's plus delta V1. For R1, I go from plus to minus, so I have to put a negative sign, and it's negative this one. When I go through R2, I go from high to low, so once again negative. For delta V2, I go high to low, again negative. And for R3, I go low to high, and hence it is positive. So this is my loop direction, and we end up getting the equation. Okay, so make sure you understand this, study this circuit and this circuit, and then everything should be good. In the next video we'll actually solve a problem where we'll apply Kirchoff's laws. Okay.